Everybody, in this lesson video, I am going to talk about the unit circle, and the first thing I want to discuss is what is the unit circle. And to talk about this, I have kind of a very abstract circle, like so. So a unit circle, kind of two key parts. First major component of a unit circle is the center is at the origin. Center at the origin, which is the point 0, 0, right here. And then we have a radius, right? Here's my radius. That is 1 unit. So this stretches from 0 to 1. So radius equals 1. Which, if I follow this, I could then write this radius, right? From the center up, straight up, vertically. And this would be at y is 1. This would be when x is -1 here. And then down here, this is when y is -1. Because the radius is the same all the way around the circle. Now, if I talk about a central angle that is within a circle, we have this usually the standard initial side of our angle. It's the initial ray, which is in the positive portion of our x-axis. So here's the initial side of the angle, and then the angle will open to intersect the circumference, the outside edge of our circle at some point. Label that point P. And I can actually draw a right triangle to represent this. So we have a right triangle where the hypotenuse is the radius. The hypotenuse is 1. And then we have 2 legs. Here's one of my legs. And here is the other. Oh, maybe. All right. So again, this is a right triangle. And we actually can talk about the coordinates of this point, the x comma y that represent the positioning. And x is really this leg along the x-axis of the right triangle. So that is x. And y is the vertical distance from the point to the x-axis. This is y here. So this point is x comma y. And if this is a right triangle, and I'm talking about the central angle being formed, this then is our central angle. And maybe actually let me move this x over here. Or how about this? I'm going to move the radius part down. The x. Ooh, all of the x is what I wanted to move. Move the x down there. So x is that horizontal side. Oh my. And y is the vertical. And then this is our angle theta, the central angle that we are working with. X then is the adjacent side to that central angle theta, and y is the opposite side. Actually, let me write it over here. Now, I reference all of this because in right triangles, we have these trigonometric ratios, and we use that acronym SOHCAHTOA to help us remember. So let's talk about the sine, cosine, and tangent of this angle theta here that I've defined. And let's actually start with cosine. So I'm going to talk about the cosine of that angle theta. And cosine is equal to the adjacent side, A, over H hypotenuse. So in this triangle that I've drawn, the adjacent, that is X, over the hypotenuse, which is 1. So the cosine of this angle here is really just equal to x. The sine of the angle, the sine of theta, is equal to, sine is opposite over h is hypotenuse. So the sine of this angle is equal to the opposite side, which is the height, right? The vertical distance y over the hypotenuse, which again, this is the radius of 1. So the sine of this angle is y. So this point, this positioning, where the hypotenuse or the radius intersects the circumference of the circle, this x comma y is also the same thing as the cosine of this angle. This is the cosine of theta, and y is the sine of theta. And then lastly, that leaves us with tangent. So leave this color. And the tangent of theta is always equal to the opposite over the adjacent, O on top of A. And the opposite again is y over the adjacent, which is x. So y over x is our tangent, which note that's also the same thing as the sine, or sorry, yep, sine of theta, y over cosine of theta. Tangent is always sine over cosine. Y is sine over x is cosine. Alrighty, so let's now talk about what we call the 4 quadrantal angles. The 4 quadrantal angles. And I accidentally already had this diagram here. So you can either copy it or print it out and paste it here. But what this is talking about are the angles formed by the 4 quadrants, right? Because our x and y axis divide this graph up into 4 quadrants. So here we have 0 degrees or 0 radians, however you want to look at it. The first quadrantal angle is 90 degrees. So this is 90 degrees, or what we call pi over 2, because half of a circle, let's not forget, half of a circle is pi, or 180 degrees. So half of a half, or a quarter of a circle, is pi over 2. Oh, I don't like that. Pi over 2, which is 90 degrees. Now the coordinates of this point, right, I could write out the coordinates of this. The x value is 0 and the y value is 1. So this is the point 0, comma 1. The first point that we wrote over here, this was the point x here is 1, y is 0. The second quadrantal angle is when we are at 180 degrees or pi. It is a semicircle, and the coordinates of this point are -1 as an x value, and y is 0. And then the third quadrantal angle down below here, this is really 270 degrees, 3/4 of a circle. And if this is pi over 2, this is pi here, or 2 pi over 2. And this then is 3 pi over 2. And this coordinates, or these coordinates would be, x here looks like it is 0, and y is -1. All right, so we've labeled the 4 positions, and now let's talk about the values of cosine versus sine here. So again, we're gonna start, let's start with 0 as our angle, which also note this is the same thing as 360 degrees or 2 pi. And we'll come back to that at the end. So at this point, since this is the point 1, 0, this tells me then that the cosine of 0 is equal to 1, and the sine of 0 degrees or 0 radians is equal to 0 because x is cosine, and that is 1, and y is sine, and that is 0. All right, let's look at pi over 2. So at this point, x is 0, so this tells me here that cosine of pi over 2, or cosine of 90 degrees, is equal to the x coordinate, or 0. And the y value, 1, is equal to the sine of pi over 2, or the sine of 90 degrees, which is 1. And then I can say the tangent is sine over cosine, which is 1 over 0, or 1. All right, let's look at the second quadrantal angle here. 2/4 around. This is pi, or 180 degrees. The cosine of 180 degrees, or the cosine of pi, cosine of 180, is equal to our x value here, which is -1. And the sine of pi, or the sine of 180 degrees, is equal to 0, right? Just using the x and y values from this point. All right, let's now look at 3 pi over 2, or 3/4 of our circle. So cosine of 3 pi over 2, or the cosine of a 270-degree angle, that is really equal to 0. Oops, I don't like that. And the sine of 3 pi over 2, or the sine of 270 degrees, is equal to -1, because our y value here was -1, so that is the sine at this angle, and x is 0, so that is the cosine at this angle. So x is always sine, or sorry, cosine, because c comes before s. That's one way you can remember it. And then y is always sine. Oops. All right, returning back to 360 degrees, or 2 pi. This is the point 1, 0. So this tells me that cosine of 2 pi, or the cosine of 360 degrees, is equal to 1, because that's the x value. And the sine, or sorry, yeah, sine of 2 pi, or the sine of 360 degrees, is equal to 0. Okay. So one thing I want to remind you before we kind of move along to the next piece are the special right triangles that we have. Special right triangles. And there were two main types of special right triangles when we first looked at these. We had a 30, 60, 90. And we had a 45, 45, and 90. Okay, so let's, for both of these, talk about when the hypotenuse is 1, because that's normally going to be the case when we're talking about the unit circle. The hypotenuse of any right triangle that we draw is going to be 1. So let's first draw 30, 60, 90. I'm going to draw it. Here's our hypotenuse. Here's my short leg and my long leg, like so. It's not perfect, but that's okay. So here is the hypotenuse. 1. And then I have the short leg. And the long leg. Now in a 30, 60, 90, the angle that is opposite the short leg is the smaller angle, or 30 degrees. So this is the 30-degree angle, and then that makes this the 60-degree angle. Now the key here is the short leg is always half of the hypotenuse. So the short leg is 1/2. And the longest leg, if our hypotenuse is 1, the longest leg was square root of 3 over 2. And that's really because the longest leg is always the square root of 3 times your hypotenuse. Or sorry, the hypotenuse is the square root of 3. Let's write this out. The hypotenuse is the longer side, so it is the square root of 3 times your longest leg. So that formula, that idea leads us to this. And this is something that we actually talked about in an earlier lesson. So this is a 30, 60, 90. And a 30, 60, 90, the hypotenuse being 1, the short leg then would be 1/2, and the long leg would be square root of 3 over 2. And in a 45, 45, 90 triangle, let's draw that. Here's my hypotenuse. That is 1. And this is really an isosceles right triangle. So the two legs should be about the same. This is not the best, but that's okay. So here's the right angle. And then we have our hypotenuse here. And then we have two legs. We have leg and leg. And if our hypotenuse is 1, the two legs are both the square root of 2 over 2. So we always say the hypotenuse is the leg times the square root of 2, and that produces the larger value of the hypotenuse. So one leg then, if our hypotenuse is 1, one leg is the square root of 2 over 2 in a 45, 45, 90 triangle. And in this triangle, both of these angles here are 45 degrees. All right. Let's talk about some important trig values. So we have looked at these quadrantal values. These are all important. Let's now look at other important trig values on the unit circle. All right. So to discuss this, we're actually just going to talk about the first quadrant. Here is the first quadrant of our unit circle. And let's point out that this is, so I'll do it in gray. This is 0 here, 0 radians, 0 degrees. And then this would be pi over 2 or 90 degrees. So the first way we could kind of talk about this is I could break this semicircle. If I talk about the entire semicircle, I could break it up into sixths. So 1/6 of the semicircle. Let's see, I'm going to do this in this color. Maybe it would look something like this. Here's 1/6, and then this would be, oh, come on, 2/6, maybe like so. It's not perfect, but it'll work. So let's talk about this point right here. This is, if pi over 2 is halfway through the semicircle, this would be pi over 6 here. 1/6 of the semicircle, or 30 degrees, if you want to look at it that way. And I could draw a right triangle, right, where this length from the center to the circumference of the circle, that is our hypotenuse. And then I have the vertical distance down, right? Which this is really y. And then I have the horizontal distance, which is really x. Now, pi over 6, that's 30 degrees. So this angle here, theta, is really 30 degrees. So instead of theta, I'm going to say this is 30 degrees here. Same thing as pi over 6, 1/6 of a semicircle. Now, I could actually specify what x and y are because this is a 30, 60, 90 triangle. I know the shortest side, right? y, the shortest leg, has to be 1 over 2. And the longest leg is the square root of 3 over 2. So this pi over 6, I could actually write this point has the coordinates x comma y. X is square root of 3 over 2, and y is 1 over 2. Square root of 3 over 2 is the x value, y value is 1 over 2. So this then tells me that the cosine of pi over 6, or the cosine of 30 degrees, is the square root of 3 over 2. And the sine of pi over 6, or the sine of 30 degrees, is 1 over 2, because x is always your cosine, sine is always your y. And again, this is the same as the cosine of 30 and the sine of 30 in degrees. So that is 1/6 of the semicircle, pi over 6. Now let's talk about 2/6. Let's see. Which is really just 2 times 30 degrees, or 60 degrees. So let's now have this central angle, which is 60 degrees. And that is 2 pi over 6, or pi over 3. And I'm going to actually move this square root of 3 over 2 over a little bit. Now let's draw another right triangle. In this one, we have a different height, right? This one is higher up, so the y value is slightly different, and the x value is shorter this time. We still have this right triangle being formed, and now our central angle that I'm working with here is 60 degrees. So this is a 30, 60, 90, but 30 is the top angle, and 60 is this angle that we are really working with, this reference angle. So let's label our side lengths. We now have this shortest length on this side, which is x, so that is 1 over 2. And y then is the longer leg, which would be square root of 3 over 2. So if I'm going to write the coordinates for this point, right, pi over 3, that is really x is 1 over 2, and y is square root of 3 over 2. So from here, then, I can find the cosine of pi over 3. So this tells me then that the cosine of pi over 3, or the cosine of 60 degrees, both of these are equal to 1/2 the x value. And sine of pi over 3, or sine of 60 degrees, is the opposite side over the hypotenuse, which is square root of 3 over 2. All right. So this is kind of when we divide each quadrant into thirds almost, or take the semicircle, 1 pi radians, and divide it up into sixths. Let's now look at it and divide it into fourths. So here's the same drawing. We have 0 radians up to pi over 2, which is 90 degrees. And we're going to divide this quarter of a circle into halves, which really, if I think about in terms of the whole semicircle, this is dividing it into quarters. All right. So let's see, I'm going to do this one in this color. So dividing this quadrant in half. This then pi over 2 has been divided in half. This is half of 90 degrees, which is 45. So this is a 45-degree angle here, which is the same thing as pi over 4. And we can draw that right triangle again. X here is the distance, the horizontal distance from the center to that point, where we have pi over 4, and then y is the vertical distance. And since this is a 45, 45, 90-degree triangle, instead of having just, random arbitrary x and y, I can actually say that both legs, x and y, have to be the same square root of 2 over 2. So this length is square root of 2 over 2, and this length is square root of 2 over 2. So I could say then the coordinates of this point, x comma y, x is square root of 2 over 2, and y is square root of 2 over 2. So this then tells me the sine and cosine of a 40-degree angle. 45, sorry. So cosine of a 45-degree angle, or pi over 4, that is equal to the x value, which is the square root of 2 over 2 at this point. And then the sine of pi over 4 is equal to the sine of 45 degrees. And that is the same, right? The square root of 2 over 2, because both legs, both the horizontal and vertical distances that represent x and y, and therefore the location of this point on our circle, they are the square root of 2 over 2 when our radius, and therefore the hypotenuse, is 1. Okay, please head on to the next portion of the lesson video and let me know what questions you have.